we're going to look at properties of special parallelograms today, guys. And the essential question here simply says this. What are the properties of the diagonals of rectangles, rhombuses, and squares? Let me ask you this question. You guys heard of rectangles before? You heard of rhombuses before? You heard of squares before? So there's some things in here that are going to pop up today that there's some properties about them that help us identify which shape is which, okay? So guys, to answer that question today, what are some of the properties of the diagonals of those four quadrilaterals, or special parallelograms, if you will? We're looking at using properties of special parallelograms, okay? We're going to use some properties of diagonals of special parallelograms, and then we're also going to use coordinate geometry to identify some special types of parallelograms, okay? So those are the three goals that we're after today. Vocabulary-wise, I think you should be pretty good with this. I'm pretty sure you've heard of these before, but we're going to look into some things today that make a parallelogram one of those three shapes and what properties those are to help us justify which of the three it's going to be today. So first one I have there is a rhombus. Okay, anybody want to read that one for me? Okay, so these tick marks right here, you guys see all those tick marks that they put right here in the definition? All those little tick marks, say here, here, and here, means all those sides are what, kids? They're all the same, okay? Kids, talk to me about a rectangle. A rectangle is a, okay, so if I have four right angles here, 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 and here, you definitely have what kind of a shape? A rectangle, okay? And then a square. It says a square is a parallelogram with four congruent sides and four right angles, okay? Guys, is a square a rhombus? Because all sides are what? Is a square also a rectangle? Okay, listen to what I say. Are all squares rectangles? You would say what? Are all rectangles squares, though? No. Okay, so some lengths that come with them, okay? So, guys, let's look at what we call corollaries right here. There's three rules right here today that we're going to talk about, okay? Corollaries simply mean that these are kind of some rules. Okay. That first corollary is called the rhombus corollary. Quadrilateral is a rhombus if and only if it has what, kids? You see four congruent sides, you can automatically call this a what then, kids? Rhombus. A rectangle corollary says a quadrilateral is a rectangle if and only if it has what? Four right angles. Are there four right angles here? And we just talked about that in the definition, didn't we? Square corollary says it's basically the definition again. A quadrilateral is a square if and only if it is a what and what, kids? Why is a square a rhombus? Four congruent sides. Why is a square also a rectangle? Four right angles. Okay, so that makes pretty much sense. I think you guys know that already. All right. So let's kind of go into page 2 here. Let's just jump into this right here. This Venn diagram is a great drawing. Okay. All right. Over here it says you've got some what here in this diagram. And over here you've got some what. The only thing that's going to be a rhombus and a rectangle at the same time is a what? So let me ask you this. Are all squares rhombuses? You would say yes, right? Are all squares rectangles? You would say yes. Okay. But are all rectangles squares? You would say no. And are all rhombuses squares? You'd say no. Venn diagram's a great visual to help you understand what's there and what isn't there. Okay. Yeah. Yeah. Why don't you run down and check out my truck too? Just go see what it looks like. I will. Okay. Are they behind you? Yeah. Go down to the art room and just look at it. Is Maddie Potter back here today? No, Maddie's gone today. So. Okay, example 1. Anybody want to read that for me?
I don't think you have to talk that loud. There's 2 people in here.
Well, I'm recording the lesson right now, Brent, so now your voice is all over it.
Oh, no. Carson, I already got told I don't know what a whisper is, so you don't need to make fun of me either.
Hey,
I'm loud.
Did you hear that there was a kidnapping at school today? He woke up. I knew she'd have to explain it to her. All right. Oh, I love my job. Okay. All right. Hey, it says for any rectangle ABCD, decide whether the statement is true or sometimes true. Explain your reasoning. First thing we're drawing is what shape, kids? Let's draw a rectangle up here. Now, kids, the way that they've ordered this for you, you've got to put it in order. So if I start with A right here, I got to follow order. So I'm going to put A here, maybe B right here, keep going in order, C there and D there. Okay. So we know it's a rectangle that we're dealing with, kids. What angles do I have to have in all four corners? Are you with me there, kids? Okay, so first question it says is this. It says, decide whether the statement is always or sometimes true and explain your reasoning. Okay. Guys, AB is equal to what? What's this statement say right here? AB is equal to what? Now, the way I drew it, does it appear that AB is equal to BC? No. But is there any condition where I might have a certain type of rectangle where AB, that side AB, could equal BC? If the rectangle was a what? Then AB would equal BC. So is this going to be always true, sometimes true, or never true? What would you say? Sometimes, but the sometimes for part A would be when ABCD is a what, kids? When ABCD is a square. Okay? All right. Take a look at the next one. It says AB is equal to what? These two sides are always opposite of each other, right? What's true about opposite sides in any parallelogram or any rhombus or any square or any rectangle? They're the same. So what about that statement? Will it always be true or sometimes be true? This will always be true the way it's drawn, right? Okay. And you don't really need to explain that. All right. I could just say opposite sides are always what? Okay. Does that question make sense to you? Okay, so for example 2, my friends, it says classify this special quadrilateral. Explain your reasoning. Okay. Guys, it's a four-sided shape. This side and this side is parallel, so it's definitely a what, kids? What has to be true about opposite sides then? There's a tick mark here, so would that mean a tick mark up here then as well? Oh, wait a minute. But what's true about the bottom side and the right side? They're all the same, so if all four sides are the same, doesn't say anything about angles, what do you have to say this is? Say it louder. It's a rhombus. I always wanted to drive a bus and have a trailer behind the bus. And trailer, I was going to put the letters R-H-O-M. So I could say it was a rhombus. You guys know what I really have, what's on my bucket list? Have you guys ever seen Oscar Wienermobile out on the highway before? So have I. I have this thing. I want to drive that thing. I absolutely want to drive the Oscar Mayer Wienermobile. Okay, that would be like the ultimate. Okay. All right, guys, let's talk some properties right here. Diagonal properties. Okay, anybody want to read that rhombus diagonals theorem for me? Right here, kids, it says, if you ever have a rhombus, what's going to be true about the angle formed between the two blue diagonals right here? Has to be what? 90 degrees. Okay. All right, and then it also talks about rhombus opposite angle theorems. All right, opposite angle theorem says this: a parallelogram is a rhombus if and only each diagonal bisects a pair of opposite angles. Okay. So this diagonal right here, do you see these two tick marks? Or I'm sorry, two arc marks up here at angle B? That tells it that this top angle up here is equal to this bottom angle. Guys, how about down here at C? Are those two angles equal? If the angles that are opposite of each other get bisected or cut in half, then it's also a rhombus. Okay. So in example 3, it says finding angle measures in a rhombus. It says use the diagram in example 3. It says find the measure of angle ABC and the measure of angle ACB in rhombus ABCD. So they're telling you already that this is what shape? Okay. Right up here at angle 1. Do you guys see angle 1? What does angle 1 have to equal here, kids? has to be 90 degrees. Okay, you know angle 1. I'm just going to write these all down. Angle 1 has to be 90 degrees, doesn't it? Would you agree with that? Okay. Guys, look at this 61 degree angle. If this is 61 degrees down here, what's this have to be right in here? 61. So I'm going to do this down here. I just want to do this. You know all these angles are right angles right in here, don't you? What do angle 2 and angle 3 have to equal? Because they're opposite of each other, right? It's a rhombus. They're opposite of each other. They've got to be 61 degrees also. Okay. Kids, take a look at this. Every triangle has to add up to how many degrees? 180. Do I know angle 1 and angle 3 down here? Could I find angle 4 down here? Okay. I would take 90 plus how much? 90 plus 61 is 151. What's 151 from 180? Close. 29. Very good. Very good. Okay. So, guys, I think that what we could say is this. You would have a 61 here and here. 3 and 2 are 61. Guys, angle 4 is going to be a 29 and a 29, a 29 and a 29 at angle B. You're asked to find, what angle did it ask you to find? Measure of angle what? A to what? Okay, wouldn't that be that whole angle right there? But that whole angle ABC is made up of 2 triangles in that corner, right? And that's just like angle 4. So isn't ABC going to be really a 29 degree angle here and a 29 degree angle here added together to get that whole angle? What's 29 and 29 add up to, friends? So angle ABC right up here has to be 58 degrees. Okay. What other angle do they ask you to find? ACB. We've kind of done that already.
Nice truck.
You like it?
I'm so confused. I thought you weren't getting one.
I didn't think I was either. And then they called me back and they finally gave me the amount of money I wanted for my trade.
Okay, what is
Finally, and I said, get it ready. It's kind of like my birthday present to me for turning 50 pretty soon. You know? You know what color they associate with turning 50? Yep. Yep. It's just like you're close to death. What color is associated with death?
Black.
They always say 50 is like your black birthday.
I just can't believe we're going to be driving a black truck.
What's wrong with that?
It's different.
I got a flame wrap ordered. I'm going to put some flames on it. It's all up the hood and on the sides. It'll be sweet. Yeah. Jalen doesn't think I'm serious. Oh, I'm serious. Super serial. Hey, what angle was the last one we were trying to find? Would it say angle ACB? Is that right? Oops, I got the wrong pen right here. Angle ACB. Okay, ACB. Can you guys visualize from A to C to B? What's that have to be? Kind of labeled it already. Have to be 61 degrees. Okay. Guys, if something is a rhombus, the 2 angles at each corner have to be the same, and then everything in the middle is how many degrees? 90. Okay. How do you feel about that, friends? Okay. Questions on that page at all? Let's move on. I think you've got this here. This is pretty good. Okay. Guys, now instead of talking rhombus, we've got another theorem that involves what here? Rectangles. It says a parallelogram is a rectangle if and only if its diagonals are what? Okay. If this diagonal, all these distances right here, see how they tick mark the whole thing right here? If the 2 diagonals are equal in length. Now, is there a 90-degree angle in here? No, because it's not a rhombus. Okay, because the AB might be longer than AD. You know, the top and the bottom might be longer than the left and the right. But if the 2 diagonals are the same length, then you have to have a what? Okay, so here's the deal. Suppose the diagram in example 4 is shown there. Okay, it looks like there's some framing going on. They might be putting a window in that framing. So suppose you measure one angle of the window opening, and its measure is, they tell you this angle is how many degrees right here, kids? Okay. Can you conclude that the shape of the opening is a rectangle? Yes or no? Kids, you know Pythagorean theorem, don't you? Guys, what are the legs on this right triangle that I just drew for the diagonal? 33 and what? 44, right? What are the legs for the other diagonal I would draw in here? Okay. In both cases, wouldn't 33 squared plus 44 squared have to equal the diagonal squared? For both cases? So what could you say about the diagonals? Diagonals are congruent, therefore this must be what kind of shape? I don't know how to make it much simpler than that for you guys. Now, hopefully it's not confusing, but are you on board with that? If I have diagonals that are equal, and I said one angle is 90 degrees, so I know right there that the diagonals have to be the same because got a right angle there. And aren't the opposite sides equal? So it has to be a parallelogram, doesn't it? So wouldn't there be a right angle opposite of that up here? Hey, all right. Let's try to find some diagonal lengths here, kids. It says in rectangle ABCD, AC is equal to what? And BD is equal to what? Okay, it says find the lengths of the diagonals. Well, kids, A to C is this distance right here, isn't it? Defined by what? And BD is this one right here, defined by, okay, well, if it's a rectangle and a diagonal are defined by those, what has to be true about those two expressions? What's true about the diagonals in a rectangle? So what has to be true about the two expressions, 7x minus 15 and 2x plus 25? So we're going to have to solve for x to figure out a diagonal length, right? Okay, so let's do this, kids. I'm going to subtract 2x from both sides. So am I right when I say 5x minus 15 equals 25, kids? All right, how much you want to add to both sides now, friends? We've got 5x equal what here? Right? Let's not make our x value. Now, guys, am I done with the problem here? It says find the length of the what? Okay, so let's just do A to C. A to C is defined as 7x minus 15, isn't it, kids? Only you know x is what value now. So what could I plug in for x now? Okay, so what is 7 times 8? So what's the diagonal length? What's the diagonal length there, kids? 41 is what you're going to get there. And just to check the other one, what would 9 times 2 make? Oh, I'm sorry, 8 times 2. I said 9 times 2, didn't I? Yeah, 8 times 2 would be 16 plus 25. That would also be what? 41. So x being 8 makes them a rectangle. Those two diagonals are 41 units long. Okay. Kids, I'm going quickly. Are you keeping pace with me? What questions have you got up through that example? Are we on to the last one? Gnarly. Let's knock this out of the park today, kids. Guess where I'm going to graph this? Okay, you guys remember how to make a table in Desmos? Okay, I'm going to go ahead and click Add right here. I'm going to make a table. I'm going to hold down on this up here so I can get some lines. So I'm going to click that. So I hold down that dot up there. Okay, guys, give me that first coordinate up there for A. -2, 3. Okay, next one. 2, 2. 1, -2. Oop, I messed that up. -2, you said? Okay. -3, -1. And I'm going to wrap this back up to -2, -3. Oh, I'm sorry, +3. Okay. Kids, clearly that looks like a what? Square. And if it's a square, it's also a what? And if it's also a rhombus, it's also a... I should back that up. If it's a square, it's also a rhombus and a what? Rectangle. So it's a square, a rhombus, and a what? I'm just going to write in here by decimals. We can see... Ah! The right one, Parson. Come on. So I'm going to say by decimals, we see a square, which is also a rectangle, and what else? My friends, what questions have you got for me today? Okay, I'll let you get that down. I'm going to load up a big ideas here for you. Oh, let me stop the recording first. Wait, was I recording? I hope I was recording.